Alright, so now we're just modelling charge and current in a damped system. So a few equations to look at. Now you should remember that current is going to be denoted with the letter I. And I, in a damped system, the current is going to be A e to the AT cosine BT. So you remember I flicked on my switch and the current will look something like this as it settles down. Good. So you should also remember that current and charge are related. So current is just the derivative of charge. So if charge is the letter Q, then that means that this is equal to Q dash. I can kind of write that a slightly different way. So I is equal to the derivative of Q, which is the charge, which is equal to AE AT cos BT. So if we know the current at any given time by placing in a value here, I'll also know the rate of change of the charge at that particular time, but I won't know the charge at that particular time. If I want to know the charge at that particular time, then I'm going to have to find the, so charge is going to be equal to the integral of AEAT cos BT. Now, if I find the integral of, with respect to t, if I find the integral of that, what I'm going to end up with is Q is equal to some function plus C, because I'm finding an indefinite. So what I really need to know is because C is going to be my initial charge, provided I'm given an initial charge for this, I'll be able to find out what the charge is at any given particular time, because then I'll have my whole function for what the charge is. So that's all you need to take away from this video. The current is given by this function, which is also the rate of change of the charge at that particular time. So the charge is going to be the integral of that, and don't forget there's going to be a plus C on the end, so we'll have to deal with that by having some initial value.